Let's pick up where we left off last time, that is, the types of matrices. There are many more that we still need to discuss. Now, there is a kind of matrix that is full of zeros, just like how my piggy bank used to be when I was a child. Since this matrix has all its entries as 0, it is called the zero or null matrix. It even has a special labeling O. So if you ever see a matrix called O, you'll know it's a null matrix, since all its entries will be 0. Take all these matrices lined up perfectly on your screen, for example. They are all null matrices of different orders: 2 by 2, 1 by 2, 2 by 1, 2 by 3 and 3 by 3. Since all the entries are zeros, order doesn't matter. They are all null or zero matrices. Time to look at the next type. Imagine your teacher asks you to switch seats with Ali. Maybe you are making too much noise. Because you two have exchanged places, we say that you guys have been transposed. The type of matrix we are discussing follows the same concept of exchange and transfer. Take the example of matrix A. We have A and another empty matrix where the changes will be reflected. From matrix A, take all the entries of its first row, 1, 2, 3, and place them in the first column of this empty matrix from top to bottom. Now take the elements from the second row of matrix A and place them in the second column of this new matrix. Similarly, take numbers from the third row of A and put them in the third column of the new matrix. This resultant matrix is called the transpose of matrix A and is written as A with a T in the superscript up here. So if you think about it, all we did was changing the rows of A into the columns. Okay, let me visualize it for you. Take this matrix B. Now assume that the entries are bags of sand with numbers written on them. Let's place all of them in a box. Okay, so now we have 6 bags of sands or entries in a box or matrix. Now comes the fun part. Put another empty box underneath it and push the bags of the first row in such a way that numbers 2, 0 and 1 fall in the empty box one by one, just like this. Do the same with the second row. Push, push, push till you land all the entries of the second row in this empty box like this. And before you know it, you have converted rows into columns one by one. This new matrix is the transpose of matrix B, represented by B with a small t in the superscript. Now there's one more way you can figure out the transpose of a matrix. Take this matrix C of order 1 by 2 for instance. Now, instead of interchanging the rows into columns, let's mix it up a little and try interchanging the columns into rows. The first column becomes the first row. The second column becomes the second row. Pretty neat, right? Well, that's how we get the transpose of matrix C. But if you don't like this method, just go on and use the sandbags method instead. You'll get the same result either ways, whatever floats your boat. So basically, a transpose of a matrix can be obtained either by changing the rows into columns or columns into rows. Choosing either way has no impact on the final result. Now, if you didn't already notice, the transpose of a square matrix such as A has the same order as before, whereas the order of rectangular matrices such as B and C, changes after the transpose. Interesting, isn't it? Now these were just 6 types of matrices. We have got 6 more types to go. But for that, you're gonna have to wait for our next video. See you all then.